So, hello everyone. I am Bhargav Mahajan from third year Information Technology Department. So, this is in a Python Lab series. This is the seventh experiment based on linear regression and logistic regression. Basically, linear and logistic regression are two complete different sets of supervised learning. Like linear regression is used for regression kind of problem, and logical logistic regression, which has regression in its name. Basically it is used for classification based on probability, like a sigmoid curve it takes and classified into two. We have some threshold in between to have that categories. So if passes above the category, then it is classified into another, and if it is below, then it is classified into another. So it's a binary classification is done. So like we have taken a housing data set, which is California housing, like population, median income of the house, people, number of people lives inside the house, or like all those parameters are like ocean proximity, near bay, inside the city covered, like these parameters are there. Correlation, this is a function that tells us how two columns are correlated. If one value increases, whether other columns value also increases or not. So like latitude and longitude here are like negatively correlated. Like when longitude increases, latitude decreases. When latitude increases, longitude decreases, like that. So basically it values go from -1 to +1, whereas -1 is down, negative correlation, and +1 is positive correlation. Basically the more we need more values towards the -1 or -1, we can easily predict data. So like here I have taken median income and median house value. So median income and median house value, so you can see it is 0.68% correlation among them. Yeah, it's good. I also saw another column, but these two columns are kind of easy to build a model. So yeah, I'm building one. Data.describe tells us like all the numeric columns, like in 64 in 32 columns that are numerics. We can do analysis on them, like quartile analysis, 25%, 50%, 70%, mean, median, max, mean, also standard deviation. So yeah, so like linear regression is there. One is input value and one output value. So from input value we have taken median income from that df database, so dot copy, and y df we have taken df median value, median house value, which is a target variable. So xdf dot head is like median income, xdf shape total 20,640 values in x and y. So from sklearn dot model we take 10 test split and split the data set into 80 and 20%. Random state can be 40 to anything. uh, I- if you run this in your notebook and also put the random state at 42, then now both training, my extrain and test, your extrain and test will be exactly similar. If you put the same random state, if we put another, then it may uh, classified another samples into that 20 and 80%. So yeah, x test, y test, so like 16,512 and 4,128. Building a model. So from linear model we improved linear regression metrics, that how much metric what metrics we can use on our model to check our prediction accuracy. So confusion metric, confirm metric, display mean square error. So our accuracy basically is measured by mean square error. Like mean square error is where the actual value of the value lies on the plot, and the value that we have predicted. It calculates the distance between it like sum of all the distances of all the points, and then mean it and square the mean. Basically it is actually actual minus predicted value the whole square plus actual minus predicted the whole square, like that. So linear regression is a linear regression model. The linear regression dot fit x and y train. So dot score, so it is like 45.85% accuracy. Now y prediction, so we predict a test and we got y pred at this. Now we took mean square error is 1.9 basically. So when we plot our data, so this is why thing, yeah, so this is how we plot, this is how our model made a line through the data. I know this is not accurate, but it does if we got good data set, then it would have really done the job correctly. So yeah, now the second part of the experiment. So this is a linear regression based on two, one input and one output. And now this is the second part of experiment, that is logistic regression. We already saw logistic regression in the part in the last diabetes data set. Here we use another data set like copy of sonar data. Like sonar is a metal detector. A metal detector is fitted with the sonar and it collects the data. So like here we are finding whether the object we got in front is a rock or is a mine, basically sonar. So if mine, it would be more reactive to the sonar, right? So yeah, that's the data set about the total 5 rows. This is head. What is total size? Yeah, the total size is about 208 rows. Yeah. So from sklearn.linear model, now we import logistic regression and accuracy score from sklearn.metrics. So this is data.head. We have 60 feature with 60 column is our rock or mine classifier. So in x train, in x we are basically put column 0 to 59, and y we are going to put column 60. So that what we have done here, x column x dot drop. So we have here use another technique, that is x dot drop columns is equal to 60. Column number 60 we are dropped along axis 1, that is it is a column. For row it is 0, for columns it is 1. So y sonar data 60, that is 60th column of the df sonar data. Sonar data is a data frame basically. Yeah, so dot describe here only same thing like on numerical basically all columns are numeric only except the last one. So your mean, median, standard, 25% max, you can see. So now we split training data into 10% and 90%, since we have only 208 samples. So we have to do some cut short here, like 10% and 90% training data. So yeah, x test dot shape, x test dot shape, x train, x test dot shape. So basically it is 187 and 21. So model is equal to logistic regression model dot fit extend and y train. So extend prediction, that is y pred we use in last model dot predict extend. Training accuracy and training data is basically y train, and this y train prediction we got 83%, and x test. So basically training testing data accuracy is y test, and this x test prediction, that is 76 percentage, which is good. Is good. So from now we again going to do the confusion matrix. We saw confusion matrix already in the previous experiment. So it classified 9 mines as exactly as mine, but classified true negative. Basically 2 mines it classified as rock, whereas it correctly classified 7 rocks as rock, but misclassified 3 rocks as mine, that is false negative, false positive. So yeah, it's good. Now this is our own sample. Like in diabetes also, we last experiment diabetes also we defined our own data frame. Here also we are making our own data and giving it. So this is a tuple basically. Input data into numpy, we convert it into numpy array and reshape that numpy array to -1 and 1. The model dot predict input data reshape, basically this is input data reshape, and if prediction is 0 it is r, or else it is a mine. So it gave the model gave us it is a mine, so it has written it is a mine. It basically this line is taken from a data set only. So yeah, model already knew it. So yeah, thank you.